All right, section 8.5, angles of elevation and depression. So the first thing we want to do is take a couple minutes and define the difference between the angles of elevation and the angles of depression. And the easiest way to do that is to draw a picture. So I want you to work with me here. We're going to have a lady. So let's go ahead and draw. So we have a lady standing down here at the ground, okay? And her body is parallel to the ground. So you just draw this little parallel line right here, okay? And then we have up here in the sky, we have a hot air balloon, okay? And I am certainly not an artist, so work with me, right? So we have all these strings, and we have this giant balloon, okay? It's got all kinds of fancy patterns. It's just awesome. Hot air balloon. There's a little guy in the hot air balloon, okay? So it's floating up there in the sky, and again, he's running parallel with the ground, always parallel with the ground, okay? And we have this thing we call a line of sight. So it is the line of sight. So it's looking up for her, and the line of sight is looking down for him. So that is sort of the line that is formed by looking up or looking down. And so two angles are formed here. We have this first angle in red, and we call that an angle of elevation because it's going up. It's starting at the horizontal, and it's going up. So this is elevation. Okay, so the angle of elevation is from a horizontal. So remember, horizontal is kind of like flat, zero slope. So from a horizontal, a flat or a zero slope, looking up. Okay? The other angle that is formed is this one, and that is an angle of what we call depression because it's going down. Okay, that's the angle formed from going down. So angle of depression, again, from a horizontal. I'm just defining horizontal again, flat, zero slope. Okay, from a horizontal, flat, zero slope, looking down. So angle of elevation, angle of depression. We're going to use these in some word problems today, okay? The tricky part about these word problems is knowing where to put your angles and knowing what thing it is you're looking for. You've got to reread them a few times and really make sure that your picture is accurate, okay? So here we go. An airplane flying 3,500 feet above the ground begins a 2-degree descent to land at the airport. How many miles from the airport is the airplane when it starts its descent? So here we go. Airplane. Pretend this is an airplane. As I said, I'm not a good artist. Okay, so we have an airplane, and it is 3,000 feet above the ground. 3,500, sorry. 3,500 feet above the ground. And it begins a 2-degree descent. So that means it's starting to go down by 2 degrees. And remember that depression means you start at your horizontal and you're going down. And it said that it started a descent of 2 degrees. So this is a 2-degree, whoops, not 20, sorry. That is a 2-degree angle. So let me fix that for you. 2 degrees, okay? And the question is, how many miles from the airport is the airplane? So, X. How far is it from its distance right here to get to the airport? All right, so we're looking for that distance. So we have to kind of figure out where the angles are going to be in our triangle. Right now we only know the 90-degree angle. And so what I want you to know about this is that we're going to be using a concept that we'll study later on when we do parallel and perpendicular lines. But I'm just going to teach it to you right now. We've talked about it a few times, but not much. So we have these two parallels, okay? These two parallel lines. And they are being cut by this transversal, which is where the plane is going to be flying. And what happens when you cut into two parallel lines that are cut by a transversal is you form what's called alternate and interior angles, the angles that are on the opposite sides of that transversal. So the two angles that are on the opposite sides, this one and this one, they're on the opposite sides of the transversal where the plane is going to travel, and they are between the two parallel lines. That makes those two angles equal to each other. Those are called alternate and interior. Alternate interior angles. And we know always that alternate interior angles are equal to each other. So I can put 2 in here, 2 degrees. And now my triangle has a 2-degree angle, and I have to figure out which trig function am I going to use. So, ka, or toa. So let's look at it. All right, I'm going to do this in red to kind of draw attention. Here's the angle I have. I know nothing about my hypotenuse, which means I can't use my hypotenuse in my equation because I know nothing about it. So I can't use sine and I can't use cosine. So this is the opposite side to my angle, right? It's opposite angle 2, and this is the adjacent side. That's actually what I'm solving for, so I have to use that because I need to find it. So let's fill in our equation. Since we determined we're using tangent, tangent of 2 is equal to opposite 3,500 over adjacent x. Remember the strategy I said was to put this over 1 and then cross multiply. So x times the tangent of 2 is equal to 3,500. To get x by itself, divide by the tangent of 2. So you need to do 3,500 divided by the tangent of 2. That is tricky to do on your calculator, so be really careful. You're going to get x equals this ridiculous number. And it's asking you what the distance is away from the airport, but it wants to know in miles. And we just got the answer in feet because remember 3,500 is in feet. So we're talking feet here. So we have 100,226.8 feet, but I need to know how many that is in miles. So we have to do a conversion here, which is going to be a little tricky. We have 100,226.8 feet. Okay. And there are 5,280 feet in every mile. So you would have to look that up, that conversion factor. How many feet are there in every mile? 5,280. So if I divide this by 5,280 feet, it's going to tell me how many miles I have. How many groups, right? 5,280 is 1 mile. So how many of those 1 miles do I get? So when you do that division, you actually get 19. So your answer is the plane is 19 miles away from the airport. Okay, 19 miles away from the airport. Okay, let's try another one. They get a little easier as you do them. It kind of almost falls into a pattern. So let me scroll the page, and we'll look at this one. A meteorologist, I think I scrolled too far, hang on. Yeah, here we go. A meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location. To the nearest meter, how high above the ground is the balloon? So let's draw it. Hot air balloon, again with the hot air balloons. Yikes. Okay. He has an angle of elevation as 41. So this is 41. And a radio signal from the balloon indicates that it is 1,503 feet from his location. So he's sending a radio signal. All right, it doesn't travel across the ground. It travels from him to the balloon. So this is the 1,503 meters. To the nearest meter, how high above the ground is the balloon? So this is the one we want to know now. So again, let's think about what information we have. Are we going to use so, ka, or toa? So this is the angle I'm talking about. I have to use the opposite side because I have to know what that side is. That's what I'm looking for. So cosine doesn't use opposite, so I'm going to cut that off my list. And then I have choices between opposite and the hypotenuse, or opposite and the adjacent side. And since I know nothing about the adjacent side, I'm not going to use adjacent. So I'm going to use hypotenuse and opposite, which means I'm doing the sine. Sine of 41 equals opposite x over hypotenuse 1,503. Go ahead and put this over 1. And now we have to cross multiply. 1 times x is x. And then the sine of 41, find your answer, times 1,503. You find out that this person, the balloon, is 986 meters away, or above the ground. 986 meters above the ground. Okay. The third example, the world's tallest unsupported flagpole is 282 feet high. Okay. It is in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. The shortest one. Okay. To the nearest degree, what is the angle of elevation of the sun when the shortest shadow is cast? So if we imagine the sun is out here casting its shadow, it wants to know to the nearest degree the angle of elevation. So it wants to know this angle. Okay? So that means we need to find that angle. We're wanting to know the angle of elevation. So this is the one we want to know, the angle of elevation, right? So I'm looking for, I have to find the other one. So let's figure this out. Sorry, I'm getting distracted because the lights just turned off in my classroom and it's super creepy in here at night. So let me just do this again. I want to make sure I made this clear. So we have, of course, we always have this guy and we always have this guy and they're always parallel. And I know my son's a little crooked, but let's pretend this was like sort of a straight line all the way down to this corner. I'm looking for the angle of elevation. Elevation goes up, so I'm looking for this angle because it's going up, right, from the ground up to the where I would be looking at the sun. So to the nearest degree, what is the angle of elevation of the sun when the shortest shadow is cast? Okay, so let's figure out what we have because this is the angle I need to know. So in red, this is the angle I need to know. This is my right angle. So here's my hypotenuse. I know nothing about the hypotenuse. So if you think about so, ka, toa, we're not using cosine and we're not using sine because we know nothing about the hypotenuse. This is the opposite side from my angle, and this is the adjacent side. So we're just going to plug right into the tangent. The tangent of angle x is equal to opposite, 282, over adjacent, 137. I need to get tangent undone because I'm trying to get x by itself. So I'm going to multiply by the inverse tan so that they will cancel and I'll be left with x. But if I multiply one side by the inverse tan, I have to multiply the other side by the inverse tan. So now I have the inverse tan of 282 over 137. Okay? So you're just going to go ahead and plop that in the calculator, and you're going to get 64-degree angle of elevation. Okay. On the second page of your notes, we're just giving you a couple of word problems. The first thing we want you to do is to just tell me what kind of an angle we're dealing with. So you're going to look at that picture at the top of the second page, and you're going to tell me whether or not we're dealing with elevation or depression. So here's the picture. Right? I believe you have this on your paper already. So I have this labeled as angle 1, and this one is angle 2. So what kind of angle is angle 1? Well, since it's starting here at this horizontal and going up, that is an elevation. And angle 2, since it's starting here and going down, is a depression. Okay, elevation and depression. So being able to label them is important. Now let's try to do a word problem. We have a 6-foot man who stands 12 feet from the base of a tree. So again with the tree, it says to draw the picture. So here's the tree, right? And the man is standing 12 feet away, and he himself is 6 feet tall. Okay, so he's 6 feet above the ground, and the angle of elevation from his eyes to the top of the tree is 76. So from his horizontal eyes to the top of the tree is 76 degrees. Okay? So let's find out what they want us to know. They want to know how tall is the tree. Before you go ahead and start anything, let's think about this. In another color, let's look at blue. This side is 12, which means this must be also 12. And if his height here is 6, then this must also be 6. And if we want to know the height of the tree, then really we're just looking for this distance up here. We don't need the whole tree. We already know it's starting off 6 feet tall. We just need to know how much more it is. So we're actually going to use this triangle at the top, and if I just redraw it without all the other stuff, we have x, we have 12, and we know this is a 76-degree angle. So the question becomes, so, ka, or toa? So here's my angle, and this is going to be the opposite side from my angle, and this is going to be the adjacent side, and here's my hypotenuse. So I have no information on my hypotenuse, which makes it easy because I can cross out 2 of them, and I only have tangent as an option. So the tangent of 76 degrees, remember your angle always goes with the tangent. Tangent is opposite, x over adjacent 12. We're going to set the tangent of 76 over 1, and we're going to cross multiply. So 1 times x is x, and then I'm going to have 12 times the tangent of 76. You just actually have to calculate that out. 12 times the tangent of 76, and you get 48, right? And so the top part of the tree is 48 plus the 6-foot bottom piece of the tree, which means the tree is 54 feet tall. Okay, how tall is the tree? 54 feet. Okay, one more problem. Once you're doing these problems and once you get them copied in your notes, it would be really smart for you to just go back to the beginning of the problem and just listen to it after everything's written down. Just listen to it one more time, and that way you can take some time without having to stop and write to just absorb what's being said and be able to kind of understand it. So that would be a really good thing for you to do. If the man releases a pigeon that flies directly to the top of the tree, how far will it fly away? So we're still dealing with that other picture, right? We're still dealing with the same picture from the same problem. This is just a continuation. So the man, remember, is standing down here. His line of sight, we had 76 degrees. We knew that this was 48, and he was 6 feet tall, and this was 12, and this was 12. Okay. If he releases a pigeon and it flies directly to the top of the tree, how far will it fly? So now I want this part. So I have 76 degrees. I have x, and I know that this piece is 12. I just found this piece to be 48, so it doesn't really matter, I guess, which sign you choose to use here. I just choose to use the information that was given to me in the problem and not the one I just solved for, in case I made a mistake. So I'm going to look at this, and I'm going to use my hypotenuse, and I'm going to use the adjacent side, and I'm not going to use the opposite side. So let's figure out which one. So, ka, toa. Since I'm not using opposite, I can cross out that, and I can cross out that. Cosine of angle 76. Cosine is adjacent, 12 over hypotenuse, x. Let's use the strategy we used from chapter 7. We're going to cross multiply. So 1 times 12 is 12, and x times the cosine of 76. If you want x by itself, you have to divide by the cosine of 76. So I have 12 divided by the cosine of 76 is equal to x. So you just have to do 12 divided by cosine 76 on your calculator, and it's 49.6, but I'm going to round it to 50 feet. Okay, 50 feet. What is the angle of depression from the treetop to the man's eyes? From the treetop to the man's eyes. Angle of depression. Well, we talked earlier about alternate and interior angles, and so if we were already given this angle as 76, it's going to be the same one as this. And if they're looking for the angle of depression, they want that angle that starts from the treetop to the man's eyes. So that is 76 degrees. Okay? And so that is your lesson on angles of elevation and depression. Go ahead and work on your notes and practice pages.